Right, my dear children. So now in this activity, we are checking what are the things or what kind of a thing is called a circuit, right? So here I'm going to build up a small bit of a circuit by using these dry cells. I have arranged these dry cells into a holder like this, a dry cell holder, and I have used 2 dry cells in here to provide a good current, right? And I have a switch, right? And some connecting wires with crocodile clips. So see, these crocodile clips are helpful to attach the wires into the relevant materials. It can be a switch or else a dry cell. So let's connect this circuit and we'll see what kind of a thing is called a circuit and how does a circuit is going to operate, right? So first of all, I'm going to take the bulb. So this is called as a torch bulb, right? This one is called a torch bulb, right? So, and this is the one which is called as the holder, right? So you can just take the bulb and rotate it like this way, and it will get fit onto the holder like this. You don't want to keep the bulb steady with the wires, otherwise we have to hold it now. So when you are using a holder, you just need to connect the bulb into the holder and we can connect the crocodile clips onto these 2 points. So now I'm going to connect these things like this, and the other wire to this one. I'm going to place it over here. Then I'm going to connect one crocodile clip which is coming through the bulb to this battery, one terminal of the battery, and the other terminal to this switch, right? Then the next wire to the positive terminal of the dry cell and other one to the next end of the switch. Now I'm going to turn on the switch and let's see what happens when I'm going to turn on the switch. So this is the switch. I have a handle in here. I can move this handle to here and there. If I'm going to move the handle to that position, then the circuit is closed, right? Now in this situation, the circuit is opened. So now what I'm going to do now is I'm going to close the circuit and let's see what happens. So you can see that when I'm going to close the circuit, closing means I'm going to connect all the wires and all the conductors together so that the system is enclosed. There are no any open ends in here. See, the wire which is running from the positive terminal of the dry cell goes through here and comes to here and traveling through this terminal of the switch and to the other terminal, and through these wires once again through the bulb it comes back to the home, means to the negative terminal. So this is a one closed system. There are no any openings in here. So if I'm going to open the circuit like this, then there is no bulb will not light up, or there is no brightness in the bulb. You can clearly observe it. So when I'm going to close it once again, you can observe the bulb is going to light up. So a circuit is a simple apparatus which can be used to flow electrical charges by using an electric source like a dry cell or else a battery. So this is a simple closed system which can be used to flow electric charges to operate a certain electric appliance like a bulb, right? So if you connect a motor to this thing, the motor will rotate, right? So this is this kind of a simple apparatus, a closed system that allows to flow electric charges is referred as a circuit, right? These things which are being connected to the circuit, each of the appliances which are connected to the circuit are called as electric appliances. This is the electric source, the dry cell. That's the one which provides electric charges to the circuit, right? And we use these connecting wires, switches, holders and bulbs to enclose the circuit and to allow to flow electric charges. So once again, a circuit is a simple system, a closed system that flow or that carry electrical charges. Right, my dear children? Now, in this activity, let's observe, is there a certain way, is there a certain direction, or else is there a certain way when traveling these electrical charges, right? Now, in this activity, we are going to observe whether the electric charges have a certain direction of traveling, right? So, to observe this thing, I'm going to use a simple motor, and here you can observe I have connected a simple fan, right? And one plate of the fan is drawn with an arrow so that you can identify the direction of traveling quite well, right? You can clearly identify the direction of traveling or the direction of rotation very well, right? And once again, I have some dry cells connected to holders and a switch, some connecting wires. So these are the materials which I need. Now I'm going to connect this circuit, right? I'm going to connect this circuit and let's see what happens, or is there any certain direction when traveling these electrical charges, right? So I'm going to take a connecting wire first, connect to the one end of the dry cell like this, the other end to the switch and the motor. So I'm going to take one end of the motor and connect by using wires to the other end of the switch, right? Then the other connecting wire to the other end of the motor and way back home once again to the other terminal of the dry cell. Now here you can observe I have used this red color end at my left hand side and the black color end at my right hand side. You can clearly observe it. So now when I'm going to turn on the switch, or when I'm going to enclose the circuit, observe to which direction does this arrowhead moves. Okay, observe to which direction does this arrowhead moves. Simply to which direction does the fan is going to move when I'm going to enclose the circuit. Okay, now let's enclose the circuit and we'll see to which direction does the motor is going to move, right? Observe clearly. So you can see that to the direction of the arrowhead, means for this direction. So once again check, my dear children. So when I'm going to turn on the switch, or else when I'm going to enclose the switch, the fan of the motor will rotate to the direction of the arrowhead. So in that case, the black color end is connected with the positive terminal of the dry cell and the red color terminal is connected with the negative terminal. So let's observe once again. See, it's rotating towards the direction of the arrowhead. Right. Now what I'm going to do is I'm going to interchange the two terminals. Means that I'm going to change this one, means I'm going to change the positive terminal to negative one and negative to the positive. So in the earlier case, the negative terminal was the red color one. Now I'm going to use black color one as the negative terminal and red color one as the positive terminal, like this. Now let's see to which direction does the motor is going to rotate when I'm going to interchange the two terminals, right? So let's see now. Observe the direction quite well. See? Now in this case, the motor or the fan is rotating opposite direction of the arrowhead. It moves in opposite direction to the arrowhead. See? So we can see that when I am going to interchange the two terminals, the rotation direction of the motor is going to change also. The reason behind for this scenario is when I am going to interchange the two terminals in a circuit, the direction of the current flow is going to change. Direction of the current flow is going to change. Normally we assume that conventionally the electrical charges or electric current is going to flow from positive terminal to the negative terminal in an electric source. Always in a normal electric source, conventionally the charges or the electric current flows from positive terminal to the negative terminal. So when I'm going to interchange the two terminals, the current flow in direction also interchange. So that's why the motor will rotate to the other side when I'm going to interchange the two terminals. So it is obvious to us that in this experiment, there is a certain way, there is a conventional way in flowing electrical charges in an electric circuit. So in an electric circuit, we can say that there is a certain direction of traveling, right? So let's see to which kind of a direction does the electric charges travel or the current is going to travel, right? So we'll continue with another experiment later to observe that direction. Right, my dear children. Now in this activity, we're going to observe the certain direction or the direction of current flow or the direction of electric charges in a circuit. So I told you that in the earlier activity, there is a certain direction of travel in electric charges. And I told you that it's always traveling from positive terminal to the negative terminal. Electric charges or electric current is always traveling from positive terminal to negative terminal in any kind of an electric source, right? So now within this activity, I'm going to prove that the charges or the electric current in an electric source is traveling from positive to negative direction, right? So to demonstrate that, I have these apparatus in here. I have a center zero ammeter. Actually in this one, you can observe that the zero is not at the center, but we can observe the direction of current flow quite well because the reading is at here and the reading can rotate either to your right hand side or to your left hand side, right? It's not exactly at the center, but still the meter can rotate either to right or left hand sides, right? So according to the direction of current flow, the reading will travel to a certain direction and we'll observe what will happen to the motor when this reading is going to turn to a certain direction, right? So first of all, I'll set my apparatus. So I have the ammeter, center zero ammeter with me. Then the motor, some connecting wires, some dry cells and a switch. So now I'm going to connect the circuit and we'll see whether there is a certain direction or else whether the electric charges are being traveling from positive to negative terminal, right? So I'm going to connect my apparatus like this. One end to the motor, negative terminal. So this is my, now in any kind of a ammeter, milliammeter, galvanometer, voltmeter, in any kind of a electricity measuring instrument, you can observe two terminals in here. Actually there are three. That's two. There are three terminals to make or to connect several or different types in different ways, right? So most of the times you will be having two different terminals. One is a black color one and the other one is a red color one. If you take any kind of a milliammeter, ammeter, voltmeter, or those kind of electrical instrument which can be used to measure electricity, there are two distinct, most of the times two distinct terminals, red color one and a black color one. Now here you can observe two red color ones, but both the terminals are same as they are red. So if you check clearly, this red color one is a positive one and the negative one is the black color one. Here you can observe the negative sign as well in the black color terminal. So normally in any kind of a electricity measuring instrument, the black color terminal is the negative terminal and the red color one is the positive terminal. So when you connect this red color terminal, with the positive end of the dry cell or the electric source, the positive end, this one, with the positive end of the dry cell, the instrument or this apparatus or the milliammeter in here should turn to positive direction. Here you can observe two directions. 0 is here. This is the negative direction. See this one, clearly observe the reading. This is the negative direction. This is the positive direction. So when I'm connecting this red color positive terminal to the positive terminal of my dry cell, the reading should travel to positive direction. And to observe the direction more conveniently, I have used a motor here. So the motor direction should also be the same as the direction of this reading. Now let's see whether this thing is happening or not. Alright then. So I'm going to connect this positive terminal with the positive direction. So this is the positive terminal. This is the positive terminal of my dry cell. So I'm going to connect the positive with positive here through the switch. This is to the switch. Then okay. So here now the positive terminal goes to the positive terminal of the dry cell, positive to the positive, right? Then the negative terminal. I'm going to connect with the negative terminal. I'm going to connect with the negative terminal of the center zero ammeter in here, right? And it runs through the motor as well. You can see that it runs through the motor as well. So here I'm going to connect it. Now if the current is flowing just as same as positive to negative direction or else positive to negative terminal, if the current is flowing to from positive to negative terminal, Okay, then my reading should turn to positive direction, and for the same direction the motor should rotate also. When I am going to close the switch, my observation would be the reading should move to positive direction and the motor also should turn to the same, or it will rotate to the same direction as the reading. Now let's see whether we can get this observation or not. Okay, so I'm going to connect it. See, you can see the reading is going to the exact the same way as I told, to the direction of the positive one. Okay, see, I'm going to connect it like this. Then you can see the reading in here. The motor is working. Motor is working. See the direction of the rotation of the motor. See, check the arrowhead. Check the arrowhead. So arrowhead is moving, or the motor is rotating exact the same way as the reading of the ammeter. Once again you can observe. See, the reading is moving to that direction, to my left hand side, and the rotation of the motor also to the same direction. Means that current is flowing from positive to negative direction. That's why the reading travels to positive direction, and also the motor rotates to the same direction as the reading. Now what I'm going to do is, I'm going to interchange the two terminals. Means that I'm going to take this positive terminal and connect it with the negative terminal of the dry cell. Here, this black color end. Black color end is the negative terminal. Right? So I'm going to connect this black color end to this end of the ammeter. This one. This is the red one, means that's the positive one. And I'm going to connect this positive terminal to the negative terminal. And let's see what happens in that case. So, if our observations are accurate, like in the earlier case, without connecting this thing, I can say to which direction does the motor is going to rotate, and as well as the reading of the ammeter. So the reading of the ammeter should travel always to the direction of current flow. So the current is flowing from positive direction to, or from positive terminal to negative terminal. So when I'm going to interchange the two terminals, the reading should travel to negative direction. Reading should travel to negative direction, means to my right hand side, this one, this side, should travel to this side. And the direction of the rotation of the motor, it also should be to the direction of the reading as well. Right? Now let's interchange and see whether we can get these observations or not. So I'm going to interchange the two terminals. So black color one goes to the red color terminal, and the red color one comes back to the black color terminal. Right, so I have interchanged the terminals now. So you can see that red color terminal is connected with the negative terminal, and it runs through here, comes to the switch, and the switch goes to the positive end of the ammeter. See, it runs to the positive end of the ammeter. So negative terminal goes through the switch and comes to the positive terminal. Means that current is now flowing to the opposite direction. So the reading should go to the negative direction, not to the positive direction. If the positive is connected to the positive terminal, negative to the negative terminal, then the reading will travel to the positive direction. If I am going to interchange the two terminals, it would travel to the other direction. Now let's turn on the switch and we'll see whether we can get the observation. So if my activity, or if the current is flowing always from positive to negative direction, then in that case, the reading should travel to negative direction like that way. And the motor should also travel to the same direction as the reading. Now let's see whether we can get this observation or not. Observe clearly, children. See, check the reading. Check the reading. See, the reading is now move to the right hand side, and the motor is also rotating. Identify the direction of rotation in the motor. So I'm going to disconnect once again. Now let's observe once more. See. See. So the motor also rotate into the same direction as the motion of the reading in the ammeter. Means that in this activity, right? See. So it's clear to us in this activity, the current is always flowing from positive terminal to the negative terminal in a electric source. So in dry cells, current is always flowing from positive to negative terminal. Right, my dear children. Now in this activity, we'll be observing how we can measure the electric charges or electric current in a circuit. So to measure electric current in a circuit, we use the instrument called the ammeter. This is the one which is called as the ammeter. So here the current is measured or current is marked in this thing. Here you can observe there is a sign for the ammeter, and the current is marked from amperes, right? Amperes. In an ammeter, the current is marked from amperes, right? So this is called as the ammeter, right? So in an ammeter, if you take an ammeter, in an ammeter we can measure somewhat heavy currents. Actually, heavy means somewhat larger currents. Okay, by using this ammeter thing, we can measure somewhat larger currents. But what if there are very small bit of currents? Now in the earlier grades, like in grade 6 and 7, you have studied that we can generate some amount of electricity by using a lime fluid. So in that case, we can't measure the amount of electricity or the amount of electric current in that situation by using this ammeter. It's because that the current which is generated in that situation is very small. So to measure smaller currents in a circuit, we use this instrument which called as the milliammeter. Milliammeter. Here in a milliammeter, right? In a milliammeter, you can observe simple M and capital A in here, which stand for the milliammeter thing. And in a milliammeter, the scale is marked from milliamperes. Scale is marked from milliamperes, right? So to measure very small currents, we use the instrument called the milliammeter. To measure very small currents, we use the milliammeter. Now I'm going to show you how we can apply these ammeter and the milliammeter in two different occasions. So for that, I have arranged these materials and to prepare a circuit. So what I'm going to do is, I'm going to take the ammeter first. Now you can see that I have two dry cells with me, right? I have two dry cells with me. Means that when you're providing two dry cells, it's going to provide some amount of an electricity, right? Somewhat not that much large, but still it's way more larger than this milliampere thing, right? So when I'm going to use 2 or more than dry cells, right, I'm going to use the ammeter thing. That's the more convenient one. We can't measure by using the milliammeter if I'm going to use several dry cells. So I'm going to use the ammeter first, and I'm going to connect this positive terminal with the positive end of the dry cell, right? Positive to positive always. And there's another case, my dear children. That thing is, when you're connecting an ammeter, always the ammeter should be connected in a series connection. Series connection means when you're connecting this ammeter, the current should flow through the ammeter and to the other instruments. It should travel through the ammeter like this and to the other instruments, right? So you can't directly connect like this. You can't connect directly like this, and you can't give a different connection to the other terminals like this. Always apparatus should go through the ammeter and they should travel back to the whatever the electric source. So that kind of a connection is called a series connection. So I'm going to show you how a series connection works in this thing also. Right now, this is my negative terminal. Then you can see the black color terminal. Now I have connected this positive terminal to the positive end of the dry cell. Now what I'm going to do is I'm going to take the switch and the bulb, right? Take the switch and the bulb. So I'm going to connect this negative terminal to the one end of the bulb like this. Okay? Means that when current is passing through the circuit, right? It goes through like this, and through the ammeter, through the bulb to the other one. So this kind of a connection is the one which is referred as a series connection. Means that current is passing through the ammeter to the other instruments and way back to once again to the negative terminal in a dry cell. That's how a series connection works. Right now, I'm going to take the other connecting wire which goes through the switch and which comes back again to the negative terminal of the dry cell. Right. Now, I'm going to turn on the switch and let's see how or what kind of a reading will the ammeter is going to give. Okay. Right. So I have turned on the switch. So here the reading is just moving to my right hand side, and it's very small, right? Here there are 10 divisions. From 0 to 1 there are 10 divisions. From 0 to 1 there are 10 divisions. Means that one each division, 0.1 amperes is one single division. So here you can observe from 0 the reading has traveled 1 and 2 smaller divisions. Means that the current passing from the circuit is 0.2 amperes. In this circuit, the current which is passing is equal to 0.2 amperes. Right? 0.2 amperes. So there are 0.2 amperes in the circuit. Right? Now I am going to disconnect the circuit. And the other case, when you are connecting these ammeters, remember there are two terminals which are referred as the positive and the negative terminal. In the earlier activity also I told you that in any kind of electricity measuring instrument there are two distinct terminals marked from red and black color. Red color one is the positive. So red color terminal should always connected to the positive terminal of the electric source. Remember that thing. That's really important when you are connecting these instruments to the measuring instruments to a circuit. Right? Always the positive terminal should run to the positive terminal of the electric source. Now I am going to disconnect the circuit. Now I am going to take the smaller instrument or the smaller ammeter, which is referred as the milliammeter. When you take 1 milliammeter means 1 of 1,000. 1 of 1,000 from an ampere. Now I told you that when you take this ammeter thing, in an ammeter the reading is marked from amperes. In a milliammeter the reading is marked from milliamperes. So 1 milliampere means 1 of 1,000 from amperes, right? When you divide 1 ampere by 1,000 units, when you divide 1 ampere by 1,000 units, you can get a one value of a milliampere. Okay, so here you can observe it's been marked up to here 100 milliamperes. 100 milliamperes. 100 milliamperes means 100 units of 1,000. Means in amperes this value is just 0.1. This is just 0.1. 100 milliamperes means just 0.1 of amperes. So when you take this thing, it's been marked from amperes, no? So 0.1 amperes means just one smaller division. Just one smaller division. So when I am going to connect this circuit, you can observe the reading is going to travel. There are 3 divisions. You can observe there are 3 divisions now. So current in this circuit is 3 divisions now. 3 divisions means 0.3 of amperes. 0.3 of amperes. Now I am going to disconnect this one and I am going to connect this milliammeter to my circuit. So you know that I told you earlier, in this milliammeter we can measure only 100 milliamperes. 100 milliamperes means, my dear children, only 0.1 of amperes. So when I am going to connect this thing to the circuit, we can't get an exact measurement. The reading should run way back to the other end and we can't get a definite idea or exact measurement. It's because that in my circuit, in this circuit, I have 300 milliamperes or 0.3 amperes. But in this milliammeter, I have only 100 milliamperes, 0.1 of amperes. Now I'm going to connect and show you that we can't measure current in this circuit by using the milliammeter. So I'm going to connect this thing now. Positive to the red color one. See, red to red, positive to positive, negative to negative. Now I'm going to turn on my switch. This is the bulb here. I'm going to turn on my switch. Bulb should light up, but the reading should go over 100. That should be my observation. So can you check the reading? The bulb is going to light up and the reading is traveling way more than the 100 milliamperes. It's because that the current which is given from this circuit is very much larger to measure by using the milliammeter. So I'm going to disconnect, otherwise my milliammeter would break. So I'm going to disconnect. So what is the purpose of using a milliammeter then? So I told you milliammeter is being used to measure very smaller currents. So I have a button cell with me. See, I have a button cell with me. This is called as a button cell. These button cells are being used. These button cells are being used in washers, sometimes in smaller remotes, in AC controllers, right? These button cells are being used. So this is a button cell, and this button cell is also somewhat being used. Means that the amount of electricity in this button cell is very small now. right? So first of all, I'm going to use the ammeter, and let's see whether we can get a definite reading from the ammeter, right? So I'm going to connect. In these button cells, the positive and negative terminals are at up and down, right? So I'm going to connect it. There is a very small deflection, right? This deflection cannot be exactly measured as it is very small. See, we can't measure it clearly, right? It's because that this button cell is giving very small bit of a current. So if a very small bit of current is given, to measure that smaller currents, we use the instrument, the milliammeter. So now I am going to connect the milliammeter, and let's see how much is my reading, right? So here we go to the milliammeter. Let's connect and see. Now you can observe it's going to like 20, 25. So it runs up to 40. So this is the use of this milliammeter instrument. We can measure very smaller currents by using the milliammeter. To measure somewhat larger current, we use the other instrument called the ammeter. Ammeter, the scale is marked from amperes. In a milliammeter, scale is marked from milliamperes. 1 milliampere is 1 of 1,000 from 1 ampere, right? So let's head on back to our classroom and we'll observe what are the other things in the lesson. Right, my dear children. Now, here I have several batteries and dry cells, right? So first of all, I'm going to let you know what do we mean by a battery and a simple dry cell. Now, these type of instruments or these type of electrical sources are referred as batteries. These things are somewhat larger than these dry cells, right? Larger than these things. Specialty in these things is that we use a special type of an acid with some metals, right? These are also called as lead acid accumulators. Lead acid accumulators. So there are several knobs in here, right? There are several knobs in here, right? We can remove these each knobs, and if you want, you can add the acid when time is going to pass by. The strength of the acid is going to reduce. In that kind of a situation, you can remove these pins by using a spanner or else a screwdriver, and you can insert the acid onto this lead acid accumulator. So these things are very heavy. For vehicles, we use these lead acid accumulators, right? And these things are called as dry cells. These are dry cells because we use dry materials or dry chemicals in making dry cells. So now we are going to observe what is the voltage value or the potential difference in each of these electrical sources. So first of all, I am going to take this lead acid accumulator. So most of the times in a lead acid accumulator or else in a battery, right, the specifications are printed in here. Specifications are printed in here. So you can observe it's saying that 12 volts. 12 volts. You can see there is 12 volts. So 12 volts means the potential difference. The potential difference or the difference between the electrical charges of the positive and negative terminal in this battery or the lead acid accumulator is about 12 volts. 12 volts, right? So it has 12 volts of a potential difference. So if you check it clearly, you can observe in the figure here. See, in this figure, you can observe there is 12 volts clearly. Okay, now I'm going to take each of these dry cells, right? First of all, I'll take this square shaped dry cell, this one. This dry cell is a 9 volt dry cell. This one. This is a 9 volt dry cell. Positive and negative terminals are printed here. So this terminal, this one is the negative one, and this terminal is the positive terminal, right? This is the negative terminal, this is the positive terminal. So here you can observe the 9 volt sign can be clearly observed in here, right? The 9 volt sign can be clearly observed in here. So this is called as the 9 volt dry cell. So the potential difference or the voltage of positive and negative terminal, or the difference between the electrical charges between positive and negative, is equal to 9 volts. 9 volts in this one. 9 volts. The potential difference is 9 volts in this dry cell. And I have another dry cell. Most of the times we use these dry cells for our torch, flashlights, right? So in here, let's see how much is the voltage in this one. So if you observe this end, see, you can observe the 1.5 volt sign. See, the 1.5 volt sign in here. So you can clearly observe the 1.5 volt sign, right? In here, see, you can observe. So the potential difference between positive and negative terminal of this dry cell is equal to 1.5 volts. Normally in these torch batteries, like these things, and these batteries which we used in our remote controllers, right? These batteries have 1.5 volts of a potential difference. So here, let's see the potential difference of this one. If it is being printed, we can see it clearly. So in this dry cell, the smaller dry cell which we used in our, most of the times they have been printed, but there are some certain cases which the potential difference is not printed in a dry cell. So in this dry cell, we can't observe the potential difference. But if you take these dry cells also have 1.5. Normal dry cells that we use, right? They have 1.5 of volts, right? And I have another dry cell, this one. This is a rechargeable dry cell, a rechargeable one. And here you can see that, it's saying 3.7 volts and LiION. This refers to lithium ion. Lithium ion. Li means lithium. It's a type of a metal. So you will learn about lithium and all the other metals in your next grades. So these batteries, especially these lithium ion batteries, lithium ion batteries, we can recharge these batteries. So this is also a rechargeable battery. We can recharge and reuse these batteries. Okay, these dry cells can be recharged and we can use in different types of occasions. These dry cells we can recharge and reuse. And I have a very smaller dry cell like this. This is referred as the button cell. It's the button cell. So we use button cells most of the times in clocks and watches. In wristwatches we use these button cells. In a button cell, the positive and negative terminals can be observed See here, you can observe the positive terminal. So this end is this top is the positive terminal, right? Here you can observe the positive sign. See, the positive sign can be observed here. And this end, this is the negative terminal. This end, the other end is the negative terminal. So these button cells are very smaller. Normally they have like about 2 volts most of the times, or 1.5, 1.7 volts, right? So we use these button cells or button cells in our wristwatches or in clocks, right? So these are the types of different batteries and dry cells that we come across in our day-to-day life, right? So remember, in normal dry cells like these and these, they have 1.5 volts. These, the 9-volt batteries, right? And the larger one, the lead acid accumulator, this one will be getting most of the times as a 12-volt one. Okay, so these are the more often dry cells and batteries that we can observe in our normal day-to-day life, right, my dear children? Now let's see how to measure the potential difference or the voltage in these dry cells and batteries that I have. So I have the instrument which used to measure the voltage of a certain electric source. So this is called as the voltmeter. This instrument called the voltmeter. So we use voltmeter to measure the potential difference or the voltage in a certain electric source. So like in the ammeter, you can observe the V sign which stands for the volts or the voltmeter, and the scale here, the scale is marked from volts. The scale is marked from volts. Check the upper scale, not the below one, but the upper scale, this one. The upper scale from here to here. In the upper scale, you can observe from 0 to 15, right? So like in the ammeter, you can observe the scale, but in volts from 0 to 15 in here. And there is another scale at the below, starting from 3. Can you see that in here? You can observe 3. And you can see here, there are 3 terminals, 1, 2 and 3. And one terminal is being marked with 15 volts and the other with 3 volts. So I told you in the earlier ammeter case, it's very convenient to use, or it's easy to make our work easy, or to connect in different instruments. We use these terminals. But the actual case in here is, if I'm going to plug in this to the 15 volt, if I'm going to plug in this thing to the 15 volt, then I have to use that 15 volt scale. To measure somewhat larger currents, we can use the 15 volt scale. So if I'm going to plug in this thing to the 3 volt thing, then we can measure by using the other scale, the smaller scale, 3 volt scale. So that's the use of these 2 terminals in here to measure somewhat larger volts and some smaller volts values, right? So now, first of all, I have here with me a somewhat larger battery, right? This battery is the lead acid accumulator, right? A car battery, right? So I'm going to now plug into 15 volt scale, as this is going to show somewhat larger value. I'm going to plug in for 15 scale, and now I'm going to connect these two to the terminals to observe how much of a volt is given from this lead acid accumulator or the battery. Now let's connect and see. I have connected to the 2 terminals of the lead acid accumulator, and let's observe how much is the reading is at more than 12.5, more than 12.5, because you know that from 10 to 15 there are 5 units. So exactly at the middle you can observe the 12.5. Exactly at the middle you can observe 12.5, but it's somewhat greater than 12.5, means that the reading is somewhat greater than the, see, the reading is somewhat greater than, just a one single unit greater than 12.5. So it is about 13, but greater than 12.5 and between 12.5 to 13, right? So this is my lead acid accumulator. It's about 13, right? Greater than 12.5 and it's about 13, the voltage. So now I am going to take the other smaller dry cells to measure the potential difference, right? I'll use the smaller dry cells to measure the potential difference, right? So let's measure the potential difference of these smaller dry cells now. Right now I'm going to check the voltage of this 9-volt dry cell. So here you can observe the 9-volt thing. See, the 9-volt thing can be clearly observed. Now let's see whether this dry cell gives a 9-volt of a potential difference when I'm going to connect it with the voltmeter here. So the positive end with the positive terminal and the negative end with the negative terminal. Okay. So you can see here the scale is somewhat less than 10. See, the scale is somewhat less than 10. Means that it is about 9. So the potential difference in this dry cell is accurately printed, 9 volts, right? So this dry cell contains 9 volt of a potential difference, right? So let's see. This one, right? So this is a normal flashlight cell, right? So in here you can observe, right, it's printed 1.5 volts. Here you can observe it's printed 1.5 volt. So now to measure 1.5 volts by using this voltmeter, I need to change the scale from here, means from 15 to 3. It's more convenient to use the smaller scale. So first I am going to eject this thing and plug it to 3 volt thing here. Now my scale is from 3 volts. Okay. So in here I have to use not the top scale but the bottom scale. So bottom scale is the one which is running from 0 to 3. Alright, now let's connect and see. Positive with the positive terminal and the negative with the negative terminal, like this. So check the smaller scale, my dear children, not the top scale but the bottom scale. Check that one. Here you can observe 1, right? Below 5 you can observe 1 and below 10 you can observe 2. So the reading is exactly between 1 and 2, means the potential difference or the voltage in this dry cell is exactly 1.5 as it's been printed on the dry cell. We can get more accurate readings if you use the smaller scale when you are measuring smaller values of voltages. Right. Now I am going to use the other dry cells also. Now you can remember this is the rechargeable dry cell, right? So here it's been printed 3.7 volts but it haven't been charged up to its full potential. So now the potential difference is somewhat low as it's been dried up. So let's see how much of a volt has been remained within this dry cell. So I'm going to connect once again with the positive with positive and the negative one with the negative terminal. Right. So it's very less amount of a potential difference. See, very less amount of a potential difference can be observed. So very less. Actually, we can't observe a good value in here. Yes, like about, see, very small, because the dry cell is being dried up. We have to recharge it if you want to get a good potential difference, right? So it's about like 0.2. It's about 0.2 of volts, right? So from 3.7 volts, right? From 3.7 volts, it's just so it is just showing only 0.2 because the dry cell has been dried up. Right, now the next one. The dry cells that we used in our remote controllers, right? The AAA size batteries. So we'll see how much is the potential difference in this one. So here, once again it runs to 1.5 volts. You could remember in the earlier activity I told you that these normal remote controller batteries are having about 1.5 volts. So my dry cell that I have right now, right, see, it's showing exactly 1.5 volts. See, 1.5 volts, right, the remote batteries. Then I have a small button cell, right? Now let's measure the potential difference of this button cell as well, right? So once again, I'm going to measure. So here, so I have connected, it's very small. See, it's very small. So I have connected the two terminals. So here you can observe like about 1.5 volts. 1.5 volts of a voltage can be observed. This dry cell is also dried up, right? When time is going to pass by, the electrical charges contained in a certain dry cell will dry up, right? So if the dry cell or the battery is rechargeable, then we can recharge it. If not, we have to throw it away, right? And we have to remove it and we have to replace it with another one, right? So here you can observe it's about 0.5 volts, right? 0.5 volts, right? So these are different types of dry cells that we can come across in our day-to-day life, and their voltages. So normally the voltage is being printed, but to make sure those values, I have measured the voltage by using a voltmeter, right? So let's discuss the further things related with the lesson at our classroom then. Right, my dear children. Now let's see how to measure the voltage in a certain circuit, right? So I have a voltmeter here with me. Now in this case, I'm going to teach you how to connect a voltmeter to a circuit and to get accurate readings by using this voltmeter, right? So always when you are connecting these voltmeters, we have to connect the voltmeter in a parallel connection. We have to connect the voltmeter in a parallel connection. Parallel connection means whatever the electric appliance which is connected to the circuit, and if you want to measure the voltage of that electric appliance, you have to directly connect these plus and minus terminals of the voltmeter to that electric appliance. You have to directly go and plug in these two terminals. That kind of a connection is referred as a parallel connection. So when I'm doing this activity or when I'm conducting this activity, you can observe how does a parallel connection works or how to connect a parallel connection more accurately. So let's conduct the activity and we'll see how to connect this voltmeter. Right, so I have several instruments in here, dry cells, a holder with a bulb, a switch, then my voltmeter, some connecting wires and a motor. So these are the materials that I have. So now I'm going to connect each of these instruments and let's see how to connect the voltmeter in each of these instances. So first of all, I'll remove the motor and I'll take the bulb. So I have the bulb with me right now. So I'm going to connect by using my connecting wires the bulb to the circuit. So I have the switch here with me. One into the switch, another connecting wire, one into the bulb or the holder, right? The other into the other terminal, then once again back to the other dry cell. So this is the way of connection. Now you can see that I haven't connected the voltmeter yet. See, my voltmeter is in my hand right now. I haven't connected it, but my circuit is completed here. My circuit here is completed, right? So when I'm going to turn on this thing, the bulb should light up. See, you can observe it. The bulb has been lighted up. So in the earlier case, when we are connecting the ammeter, I have connected the ammeter so that the current flow through the ammeter and travel to the other appliance. But when connecting this voltmeter, we can't connect that voltmeter in that kind of a connection. So the earlier connection was referred as the series connection. Here we have to connect in a parallel connection. So parallel connection is like this. Now I'm going to disconnect this thing, right? Parallel connection is, now we are going to measure, now we are about to measure the potential difference or the voltage of this electrical appliance. So this electrical appliance is the bulb. So in that case, I have to connect for these two terminals, the terminals of the voltmeter, right? We should directly connect it to the two terminals, not through it like the ammeter. So now I am going to connect. So always check about the positive and negative terminals. So my red wire here starting from the positive terminal runs back and comes to the switch, and this is that positive terminal. So my red color should go to the, so this is the red color terminal of the voltmeter. Then black color terminal to the other one. Red color terminal is the positive terminal, black color one is the negative terminal. So here you can see that this is the positive terminal of the dry cell, which runs from here and comes to the switch, and from the switch it goes to here. So this is the positive terminal. So positive terminal is connected with the positive terminal of the voltmeter also, and negative with the negative terminal, right? Now I'm going to turn on the switch and let's see how much of a voltage can be obtained from this circuit, or how much of a voltage is flowing through this bulb. So I'm going to turn on and let's see. So the bulb lighted up. So we'll see the reading here, how much. The reading is, so here once again children, now I have plugged this terminal to 3 volt scale. So we have to get the 3 volt scale from here, right? So take the bottom scale, not the top one. So it passing somewhat 2.3. It's greater than 2.3 volts. So you can see 2.3 volts in here. So the voltage passing through this bulb is now 2.3 volts. So this is how to connect a voltmeter. So how we can observe whether a connection is a parallel connection? There is a more easier way to observe a parallel connection, right? It's like this. Now I told you that the voltmeter is connected in a parallel connection. So here you can observe 2.3 volts. Now I am going to show you how we can more conveniently, or how we can easily observe whether the connection is a parallel or a series. So you know that voltmeter has a parallel connection. So in a parallel connection, we can remove that appliance without troubling the other appliance. So if you remove this voltmeter from the circuit, there is no effect for the bulb, right? In a parallel connection, that's how the system works. Now, if you check your household electric circuits, means that in your houses, when you check those electric circuits, right? Those electric circuits are also have a parallel connection. When you turn on a switch in your room, only your room bulb will be lighted up, right? So when you turn on a fan in your room, the fan will work, right? If you want to disconnect that fan, then the fan can be disconnected by switching off the switch, right? The living room area is being controlled by a different circuit. So living room switches do not have any affection, or do not have any effect on the switches of your room. Living room is a different connection or different circuit. Your room is a different circuit. So that's how the parallel connection works. Now I'm going to show you that. I'm going to remove this. See, so I have disconnected the voltmeter, but still the bulb lights up. It's because that the voltmeter is having a parallel connection. Voltmeter is having a parallel connection. This is how to easily identify a parallel connection. If I'm going to disconnect a certain instrument from the circuit, even though I'm disconnecting it, the other instruments work, right? See once again. Now I have connected it. Once again it runs back to 2.3. And also the bulb is lighting up. When I'm going to disconnect it, bulb is going to still work, but the reading is not there. It's because that now this unit is not being connected with the circuit. So this type of a connection is the one which is referred as a parallel connection, right? So in a parallel connection, we can just remove the instrument without troubling without hurting any other electric appliance. Even though we are going to remove the appliance, the other appliances are going to work if the connection is parallel. So this is the most easiest way of identifying a parallel connection. Right, now I'm going to turn off this thing and we'll connect the motor by removing this bulb. So I'm going to remove the bulb and now I'm going to connect the motor, right? Now I'm going to connect the motor. So here, let's connect the motor. Right, so I have connected the motor. Now once again, you know that voltmeter should be connected in a parallel connection to measure the voltage of this motor. So now if I'm going to turn on the switch like this, you can see the motor works, right? It rotates, right? The fan is going to rotate. The fan is rotating, means that the motor is working. See? So the current is flowing through the motor. So there is a potential difference in the motor. So to check that potential difference, once again I am going to use my voltmeter and I am going to connect. So when you are connecting, check the terminals very carefully. So once again, this is the positive terminal, the red color terminal, which runs through the switch and which comes to this red color terminal of the motor. So my red color terminal of the voltmeter should go to this one like this, and the black color terminal to the other terminal of the motor like this. Right. Now let's turn on the switch and we'll measure the voltage in here. So the motor is rotating and the potential difference inside the motor is somewhat around 0.1. See, it's about 0.1. If I'm going to disconnect this thing, see. So it's about 1 volt, not 0.1, it's about 1 volt. See, the potential difference of the motor is about 1 volt, somewhat greater than 1 volt. So we'll assume that it is 1 volt. So the potential difference in the motor is 1 volt. You can observe the motor is working and the potential difference is 1 volts. Right? 1 volt is the potential difference in the circuit of the motor. Right? So I'll disconnect once again. See? This is the positive end of the motor. This is the negative terminal of the motor. So once again I'll connect. This is the negative terminal which runs to the negative terminal of the motor. And this is the positive terminal which runs to the positive terminal of the motor. So here once again you can observe the voltage. Voltage is 1 volt, about 1 volt. Right. So I'm going to remove the voltmeter once again. So you can see that as it has a parallel connection, still the motor works. So now I'm going to turn it off, and let's connect both the light bulb and the motor to check the voltage. So I'm going to disconnect this thing. So now in this connection, when we are connecting the motor plus the light bulb, I'm going to use a parallel connection. Means that the electricity comes through the bulb and runs through the motor and goes to the dry cell. Right? So let's connect in that kind of a way. So here we go. One end to the switch like this. So I'll disconnect the electric source. So this is the positive terminal which I'm going to connect it with the motor. Then after that, this is my light bulb. So I'm going to connect the light bulb terminal to the motor. So my dear children, see how does the electricity is going to pass in this circuit. So this is my positive terminal of the dry cell. So electricity should come from, or the current should come from positive terminal to this wire and should travel through the motor and through this wire, through the bulb, through the switch, once again back to the negative terminal. So if I am going to disconnect just one single instrument like this, then the whole circuit will break down. It's because that motor, bulb, switch and the dry cells all are connected in a series connection. That's the specialty in a series connection. If you disconnect one single end, the whole circuit will break down. Right? Okay. So you could remember in the earlier case, when I'm connecting the voltmeter and when I'm disconnecting the voltmeter, even though it's been connected with the circuit or even though it's been disconnected with the circuit, there is no effect with the brightness or the operation of the bulb. Bulb is still operating. It's because that voltmeter has a parallel connection with the circuit. But in this way, if I'm going to disconnect the bulb, the whole circuit will break down. So I'm going to once again operate. See, now I'm going to turn on and let's see whether the two appliances are working or not. So here you can observe bulb and the motor both are working. The motor is rotating and also the bulb is lighted up. So when I'm going to disconnect, just a one single disconnection is enough. So if I'm going to disconnect this thing, both of them will not work. It's because this motor and the bulb is having a series connection. If you disconnect, just a one single instrument is enough to break down the whole circuit. Right, once again, if you connect this thing, it will work. See? So once again, if I'm going to connect it, it will work. So when once again I'm going to disconnect, both of them will not work. So this is how the series connection works. This is how the series connection works. Okay, now I'm going to measure how much is the voltage of the motor and the electric bulb in here, right? And to get some readings. So first of all, we'll measure the voltage of the motor in here. Now in the earlier case, the voltage was around 1 volt. When I'm operating this instrument, the motor, the voltage was about 1 volt. Now let's see how much is the voltage. So I have disconnected the circuit from here. So I'll connect it once again. Now I am going to connect the motor to my voltmeter to check the potential difference or the voltage. So the positive terminal with the positive end, positive with the positive end, negative with the negative end. Right. So negative with the black color one is the negative one. So negative end with the negative end. Red color one is the positive one. So positive one end with the positive end. Right. Now let's observe how much is the voltage when I'm going to turn on the circuit. So here you can observe the reading. Reading is around 0.4 volts. You can see here the fan is working or the motor is rotating. The reading is about 0.4 volts. Now I am going to show that the voltmeter has a parallel connection by disconnecting the voltmeter. See, if I am going to disconnect the voltmeter, it won't affect. See, it won't affect the rotation of the motor or else the operation of the bulb. It's because that this one having a parallel connection. So I have disconnected it now. See, I have disconnected here. You can see the two terminals as well. So we can directly remove these in a parallel connection without troubling the others. So once again, if I'm going to connect, you can observe the potential difference. See, 0.4 volts can be observed. Right. So now I'm going to turn off the system once again and will measure how much is the voltage in the bulb. So we'll disconnect the voltmeter. Right, then I am going to connect the voltmeter to the bulb in here, right? So when you are connecting, remember to check the terminals. So let's see what is the positive and negative terminal in here. So here, this is the black color end, which is the negative terminal, comes from here. Now this is my negative terminal then. This is my negative terminal. So I'm going to connect the negative terminal, the black color one, to this thing. And the other terminal, the red color one, to other end of the bulb. Now let's turn on the circuit, or let's enclose the circuit, and we'll see how much is the voltage between the two terminals of the light bulb. Right. So you can see the light bulb is working and the motor is also rotating. We'll see the reading. See, reading is like somewhat greater than 2, means that it is around 2.1. See, it's 2.1. So you can see that when you are connecting the appliances, when you are connecting these appliances in a series connection, we can see that the potential difference between each of the appliance is going to change or is going to differ from each other, right? So this is how to measure the voltage in a certain appliance. Remember, we have to directly plug the voltmeter for the two terminals, plus and minus terminals in the electric appliance, right? So this connection is referred as the parallel, right, my dear children? Now in this activity, we'll be observing how does the resistance or that obstacle which is given against the flow of electricity, right? So resistance is the obstacle, you know that resistance is the obstacle which is given against the flow of electricity or the electric current. So in this activity, we'll be observing how does this resistance is going to work, right? How does the resistance is going to work? So to observe the resistance or this obstacle, right, I have three materials with me, right? These strings are here, you can observe with this brownish color, right? This is a copper string, So usually copper has very low resistance. Resistance of a copper string is very low. Means that it's not providing that much of a obstacle, against the electricity or electric flow. Same as the copper string, I have another string right here, this one, right? It has the same thickness as the copper one. So here, this one is called as the nichrome string. This is a nichrome string. Nichrome means it is an alloy which is made up by addition of nickel plus chromium. Nickel is a type of a metal and chromium is also a type of a metal. So by addition of those two metals together, the nichrome metal or the alloy is being created. So specialty in nichrome strings is that nichrome coil or nichrome strings have very high resistance. It has a very high resistance, means that nichrome is going to give a very much big or very much larger resistance, means that a good obstacle against the flow of electricity. So by connecting nichrome, we can reduce the amount of electricity or the amount of amperes, the current which is flowing in a circuit. So I have once again with me a somewhat moderately resistive one. This is a steel one, right? Just a iron string, a steel or iron string with me, this thing. It has a moderate resistance. Moderate means resistance is greater than this copper one, but is lesser than the nichrome one. It has a moderate resistance, right? Like a normal resistance. So the obstacle is also somewhat normal. So now what I'm going to do is, I'm going to connect each of these strings for the circuit which I have created in here. Positive when runs to the switch and it comes back and goes to this positive terminal of the electric source. And the negative terminal comes to here for these two crocodile clips. For these two ends, I am going to connect my string. And when I am connecting the string, this apparatus would work and the bulb will light up. For a demonstration, I can show you by turning on the switch and connecting these two. See, you can observe the light bulb is lighting up and the ammeter reading is going to move or deflect. So for these two terminals, I'm going to connect each of these strings and to observe the brightness of the bulb plus the reading in the ammeter, right? So first of all, I'll use the copper string, right? So you can observe the brownish color. So I'll use the copper string first. So I'm going to connect it here, one end to the bulb and the other end with the negative terminal. Here we go then. Observe the brightness of the bulb very carefully because we are going to compare the brightness. So observe the brightness in here, very carefully observe the brightness and check the reading of the ammeter as well, right? So the reading of the ammeter, use not the above one but the below one. The below one is the correct reading because I have minimized the ammeter reading, right? So use the below one. So it's actually between 0.2 and 0.4, means that it's around 0.3, right? It's around 0.3. You can see it, right? It's around 0.3. Okay, it's around 0.3, not exactly 0.3, around 0.3. Okay, and check the brightness of the bulb as well. Bulb is showing a good brightness and it's glowing very well. You can observe it. So reading is around 0.3 and here it's showing a good brightness. Now I'm going to disconnect. Now I'm going to connect the second one, this one. This is the steel string or the iron string, right? I have just an iron string, so I'm going to connect it with this thing. Iron string. So let's connect the iron string and check the reading. So I have connected. See the reading. So in earlier case, see in the earlier case, the reading was up to like 0.3. But you can see clearly right now, the reading has dropped back several units, like about 3 smaller divisions. See, it has dropped back like 3 smaller divisions. So it's less than 0.3, less than, very less than 0.3, much closer to 0.2 now. So here 0.2, see, here 0.2, it's much closer to 0.2, right? And if you check the brightness of the bulb, it's showing a lesser brightness. Brightness is less. So when you connect the iron string is going to provide more obstacle. More obstacle is being provided rather than the copper one. That's why the brightness is getting reduced in the bulb, plus the reading of the ammeter is getting reduced. It's because that resistance of the steel one, or the obstacle given against the current flow by the steel material or the iron material, is somewhat greater than the copper. Now I'm going to disconnect this thing and I'm going to use that nichrome wire, which has the highest resistance among these 3. So let's connect the nichrome coil to the circuit and we'll observe how much is the reading in my ammeter and what happens to the brightness of the bulb. So I'm going to connect it. Here we go then. See, the reading in the ammeter is somewhat less than, not that exactly, but it is somewhat less than. See, it's somewhat less than 1. Here 1, here you can observe 1. Actually, it's not 1. We are using the below scale, no. So it is somewhat less than 0.2 amperes. Somewhat less than 0.2 amperes. Check the brightness of the bulb. Actually, it's like just being lighted up, showing a very little brightness. The brightness of the bulb is very little. Just only the filament of the bulb is showing a small bit of a brightness, that's it. But in the earlier cases, you could observe a way more better brightness. It's because that the nichrome coil is providing more obstacle against the current flow in this circuit. So therefore, in this system, the current flow is getting reduced when you connect the nichrome coil. So that's why the ammeter reading also falls down. Plus, the brightness of the bulb also going to falls down. So now in this case, we can conclude finally, in different types of materials, in different types of strings or in different types of conductors, there are different types of resistance. And this resistance or the obstacle is giving, or this resistance is giving out an obstacle against the flow of electricity or the electrical charges in a circuit. So higher the resistance, higher the obstacle, and the current flow is going to reduce. In that case, if you are connected a certain electric appliance, the efficiency or the effectivity of the appliance would be reduced if it has a high resistance in the circuit. And if the obstacle or the resistance of the material is less, then more electrical charges would travel and the effectivity of the appliance which is connected to the circuit would be high. So this is all about with the resistance then. So we'll head on to the classroom once again to study further things related with the resistance. Right, my dear children. Now, here I have several instruments. In this cup, in this petri dish, I have several instruments. All of these electrical instruments or electrical equipments are resistors. These are types of resistors. So I told you earlier, there are different types of resistors, right? So these are the resistors which we can get in our commercial market. So now I'm going to introduce one resistor by each, right? These resistors, the smaller resistors, I'm going to keep several resistors in here. These smaller resistors, these have worm-like structure. They're like worms. See? Small worms. So these smaller structures or these smaller equipments, these are called as fixed value resistors. These are referred as fixed value resistors. It's because that their resistance or the obstacle is fixed. We can't change it. So therefore, these resistors are referred as fixed value resistors. So you can observe within the body of each in this resistor, you can see there are 4 colors. These color bands reflects the amount of resistance in ohms. How much of a ohm value, right? So these colors would reflect how much of a ohm value. To find out these values, right, we'll be discussing these things. Finding out these values will be discussed in grade 10. So up to now, you just remember these color bands or the color codes will reflect it's going to reflect the amount of resistance by these fixed value resistor, right? So each of these resistors, if you take the other resistors, they also have, see, they also have these color bands. So when you take 2 different resistors, they have 2 different, their color bands are somewhat different to each other. See, it's because that their values are different to each other. Their values are different to each other. So when you check this smaller one, not the blue one, the smaller one, it has a yellow color one and a brown color one and some other colors as well. But the blue color one has a brown color one, a black color one, and the other colors as well. So here, these color bands is going to reflect the amount of resistance in the resistors. So these are fixed value resistors, means that when you connect these 2 terminals to a circuit, this terminal and the other terminal, right, we can't change the value of the resistance. It's been fixed. So the value of the resistance is being calculated by using the color bands. This is the first type of the resistor, fixed value resistors. Okay. So now I have another type of resistors. So I'm going to remove these things, right? I'm going to take this thing now, right? And this thing and this thing. These 2. Observe these 2, my dear children. This one and this one. This instrument is called the rheostat. This instrument is called the rheostat. And this is called the volume controller. These are also type of resistors. Specialty in here is that we can move this lever here and there in this rheostat. These are the 2 terminals of the rheostat, right? These are the 2 terminals of the rheostat. So you can observe it clearly. See, these are the 2 terminals, right? So this is the lever. So I can pull and push this lever here and there, and by that way I can change the amount of resistance within this instrument. So this is called as the rheostat. So I can change the resistance in a rheostat. This is called as the volume controller. This is the volume controller. So I can turn, there is a handle in here. I can turn the handle to my left or right hand sides. I can turn means I can rotate it. See, I can rotate it here and there like this. I can rotate it here and there to change the resistance in the volume controller. You can observe volume controllers in your radios, hi-fi setups, and even in televisions also, right? So these are volume controllers. Okay, these are also a type of a resistor. Specialty in volume controllers plus the rheostat is that we can change the resistance to a certain value that we want. So these resistors which we can change the value are called as variable resistors. These resistors which we can change the value according to a desired value are called as variable resistors. So this volume controller plus the rheostat are referred as variable resistors. Then I'm going to remove these two. Then the third type. Third type is the LDR. These things are referred as LDRs. LDR means light dependent resistor. These structures are very small structures, light dependent resistors. Specialty in light dependent resistors is that according to the amount of light received by the top of these resistors, right? Amount of light received by top of the resistor would determine the amount of electric current. Means that we can change the resistance. We can change the resistance by using the amount of light which is falling onto the resistor. According to the amount of light which is falling onto the resistor, we can change the resistance in these things. Most of the times these things are used as sensors. Sensors means you know that there are some certain things when the light is going to fall, right? When the light is going to fall, the bulb automatically lights up. So in that kind of a scenario, we use these LDRs, right? So LDR is going to change the amount of resistance according to the amount of light which falls onto this top surface. So these are referred as the LDR or light dependent resistors. So these are the types of resistors that we can come across with our day-to-day life, right? So the function and how to change the resistance and all the other necessary facts will be discussed in our further lessons related to the electricity, right? So that's all about with the types of resistors then. So we'll head on to the classroom and we'll see what are the other things contained in the lesson.